Okay, we're live. What's going on? We are live right now, and I'm going to bring you into the 3i Atlas imagery as I'm going to attempt to connect us with the NASA live stream right now. Let's see if I can make it happen, and hopefully we get some audio with that as well. Okay, let's see what we got here. Okay.
Amit, kick us off.
Hi, everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025, to the Minor Planet Center. And NASA has been tracking and studying Comet 3i Atlas ever since. We're here today to give you the latest of what we know about Comet 3i Atlas and what we still want to know. But first, what is a comet? It's a small, natural solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks are interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars, from our amazing machines that have been roving the planet for 30 years to look for those things. That is something that's really important for us to learn about and discover. It could be an amazing discovery if and when we can confirm that. But 3i Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail, but just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance Orbiter, taken on October 2nd as the comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3i Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory towards the sun. I'll leave it to my esteemed colleagues to share further details, and I'd like to introduce you to the head of NASA Science, Nikki Fox.
Thank you so much. It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs. And by studying them, we can learn about the environment from basically where they formed, where they came from. This one came from a different environment from our own, and so we're already starting to see some really interesting differences to comets from our own solar system. 3i Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe And in doing so, they occasionally make major scientifically interesting discoveries, just like this one. Right away, of course, NASA's Planetary Defense Coordination Office established, they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our Sun. On October 30th, the comet itself reached the closest it will ever be to the Sun when it crossed just inside Mars's orbit, which is why the image that Ahmet just showed, he noted it was the closest instrument physically to the comet, because the comet was right inside the orbit of Mars. Earth was on the opposite side of the Sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the Sun from where the Earth is. However, it was also clear that its positioning behind the Sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system. And boy, were they ready for this event. NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve, to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask, and this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us, tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3i Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3i Atlas, not long after we discovered it from the ground. At this point, 3i Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. Now, what James Webb did, and its companion Sphere-X, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations with James Webb and Sphere-X, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just, to put this in context, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system, and that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed to higher levels of radiation than comets in our own system. Or, as I said before, it could be that the comet just formed from a region where carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it once we knew where it was. Now that the comet is near, our relatively speaking. Our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw in the animations while Nikki was speaking, the sun, of course, is at the center of our solar system. The planets are orbiting around the sun, and in this case, Comet 3I Atlas has come through on a trajectory in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas, so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big. Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that shared Jupiter's orbit around the sun, called the Trojan asteroids. Lucy was 240 million miles away from 3I Atlas, which is circled in the center, when its high-resolution LaLaurie camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. seeing a comet's coma in different lighting geometries with the sun coming from different directions is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I Atlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles, where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN, has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3i-atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. The answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early. Okay, back to you, Courtney.
This guy said the answers are going to come later on. And this is just more trash. from never a straight answer. We, and I mean we, meaning the general population, at least of the United States, has spent billions of dollars in tax money to produce these highly technological satellites that have these incredible cameras that can see planets clearly 20 million light years away. But something comes in the solar system, it just can't make it out, guys. We got to give you the infrared, we got to give you the ultraviolet, we got to give you the multi-spectrum. We're going to analyze the molecules coming off of it. We're gonna take a side angle so you can't see the right shape. We're gonna give you these digitized, horrible pieces of crap images. My Samsung S Galaxy 25 could have done a better job. Could have done a 10 times better job. Just ridiculous. Just absolutely ridiculous. What a joke. They had this from a couple weeks ago. Avi Loeb from Harvard Astrophysics was demanding, not only him, but other astrophysicists around the world and astronomers around the world were demanding the science data be released. They blamed it on the government shutdown and said that the reason why they couldn't transmit was because of the government shutdown. And now the government opens back up, gave them just enough time to create this horrible teleprompter speech. I mean, it was horrible teleprompter speech with a bunch of raggedy ass images that look like, I mean, 1950s television was better than that. With all this expensive electronic equipment they've got. I remember back in the 1970s, we had a satellite that could see if a quarter was heads or tails on the ground from space. And you mean to tell me this is the best they got and more answers are coming down the road? It's just, to me, paints complete cover up and sham. It's nothing but a scam. They're just more word salad, more trash, more horrible images as usual, more obfuscated data, more suppression, more oppression. Just a bunch of lies and word salad. The guy was just talking in circles, saying much of almost absolutely nothing. I could have got a sixth grader to do that press conference. Horrible. NASA, never a straight answer, I tell you. They're the worst, the absolute worst. They take tax dollars. They need to be exposed like Epstein. We need to come with the way we harass the hell out of this government for these Epstein files. We need to harass the hell out of NASA for these damn real photos and images that they're holding on to of what's really going on out there, and stop obfuscating images and skewing data. That's what we need to do, because we're paying for that trash. That whole press conference that they just, that theater that they just put on for us, that theater, that acting show, that bad acting job reading that teleprompter probably just cost taxpayers about $500,000 or more. Anyway, ridiculous. Just ridiculous. I personally believe that 3i Atlas is an artificially created object. That's just my personal opinion. Some people will have a different opinion. And guess what? If you have a different opinion, it's okay. It doesn't mean I'm your enemy. It just means I feel something different about it based on my own research. And everyone's entitled to have their own opinion because we live in a free will universe. My biggest red flag for this being artificial and not natural is the fact that it shifted and changes its speed and its trajectory several times. And now it's speeding up as it's moving away from the sun with non-gravitational acceleration. And for me, that just means simply this thing is intelligently controlled. Again, my personal opinion, you're free to think it's just a rock in space with ice coming off of it. I won't be mad at you, okay? But what NASA just did, it doesn't help any side of the story, whether you believe it's an asteroid or a comet or artificially created object. They just got on the TV and did word salad, showed some horrible imagery that I could have got, you know, hell, that was worse than 1950s television. We have the James Webb out there. We have the Hubble, which can see 2 trillion galaxies in the area the size of the top pin of a needle. It can see 2 trillion. It's called the 2 trillion skybook. You mean to tell me they couldn't aim Hubble at this thing and get a good image of it? We can see 2 trillion galaxies in the size, the area of the tip of a needle, but we can't see this thing coming through our solar system the size of Manhattan. They can just show us these big square blotches. That's the best they had. Black and white images, and it's crazy. Anyway, a little frustrating. What can you do? What did I really expect out of it? I expected a bunch of trash and garbage, but I said, I'm going to get on at 3 o'clock live press conference. I'm going to stream it into the network so people can get a chance to see it, just in case anything great did come out of it. But they never tend to let me down. I already know what they're going to do. A whole bunch of bull crap and hogwash. Anyway, guys and gals, that's where it's at. 3i Atlas is when it went around the backside of the sun, it created this huge, I'm talking about huge hole on the backside. And then we got that huge CME, that coronal mass ejection that happened right after. I'm gonna do a whole podcast on that. I'm going to get an astrophysicist on the podcast with me, and we're gonna dive deep into the coronal mass ejection from the sun, and some of the other anomalies that were discovered after this thing went around the backside. So that'll be a great podcast. I'll get that scheduled and set up, and I'll be back with more. But hey, thanks for taking a quick break out of your day. I wanted to give every particular angle and possibility of information about 3i Atlas. They call it 3i Atlas for a different reason. I call it Third Eye Atlas. Don't forget Atlas was a god that carried the world on its shoulders. And, you got the third eye, the 3i, the third eye. There might be a different message there other than what they want it to be. But anyway, either or, if I was 3i Atlas and I was artificial, I wouldn't stop by Earth after looking down and looking at this planet and seeing what we're doing here with trafficking young women and men, young women and boys, underaged, with unaliving our babies in the streets, with starvation, with all the things that we have, classism and everything else that we have going on this planet, I probably wouldn't stop either. I'd be like, yeah, nah. We just scanned their news feed and saw they fired a Reaper drone at a UAP just a couple of months ago. What do you think they'll do to us? They'll probably unleash their entire global nuclear arsenal on our ship if we tap into the atmosphere. So we'll just keep on going, and we'll just accelerate. We'll just get the hell out of here as fast as we possibly can. Maybe we'll come back when they stop unaliving their own babies in the streets. They're still arguing over how their sun reflects photons. Anyway, I appreciate y'all. I love y'all. Thanks for hanging out in this quick little break for the day. I'll be back again tonight. Peace.